A very good evening to one and all on the eve of World Space Week, Nashik, India chapter event on the 6th day of the week. Good evening from India, and of course, it's a very good morning in Texas. Friends, for kind attention of the viewers, let us follow certain etiquettes while watching the live program. Be in a quiet room or disturbance free location. Please turn off your camera, that is video stop, to save the bandwidth. Please remain muted, otherwise the background noise will be heard by all attendees. Use chat window to ask questions, and also we have put a website link in the chat window. On that website, you can ask the questions. Be respectful of the speakers and other attendees. And please note, it is being streamed live on NSS Nashik India chapter 2020 YouTube channel. Because our Zoom room is already full with 100 people and there were many waiting. So our earnest request to all of them, please view this program on YouTube channel. Our today's program agenda is, I'm not going to take all these things. I'll go straight away to introduction of the speaker, then presentation by the speaker, then speaker discussion and question and answer, and announcement about the tomorrow's program. So I'm going to skip all these things. Let me take, because today's subject of the presentation is about the educational and career opportunities in space technology. Let me tell you my experience. In 2018, I had attended an International Space Development Conference in Los Angeles, and I was really surprised and little shocked to see 106 students from India participated and won the ranks, first rank, second rank, third rank. And in 2019, that is last year, there were 203 students from India. And they were ranging from grade 6 to grade 12. They participated and received prizes. And they were all from Hyderabad, Bangalore, Vijayawada, and hardly one or two people from Pune, Mumbai. These are some of the photographs with the students who had participated and won the prizes. And this is how the certificate is given by the NSS to these people. Hi, Anita. Do you remember this?
Yes, I do.
Okay. I was really fortunate to meet Anita at ISDC 2018. Now, for our program agenda for today, our most eminent speaker of the day is Anita Gale. She is Senior Project Engineer in Space Shuttle Payload and Cargo Integration, Boeing Company. She is a retired Space Shuttle Engineer from NASA, and she is the Director of National Space Society and also Secretary of the Board of Directors of National Space Society. The subject of her presentation is educational and career opportunities in space technology. She is going to be assisted or help or co-presenter, Mr. Abhishek Agrawal. He is from New Delhi. Now, introduction of the speaker. Anita Gale is a senior project engineer in Space Shuttle Payload and Cargo Integration for the Boeing Company in Houston. Her professional career started on the Space Shuttle program in way back 1974 for Rockwell International in Downey, California. She provides conceptual designs for cargo integration on future launch vehicles, contributes to R&D for shuttle upgrades and future missions of both reusable and expandable launch vehicles, and develops and fosters process improvements. She holds 3 US patents on launch vehicle payload interface standardization and containerization, which are essential technologies for reducing future vehicle processing costs and schedules. In 1984, Anita co-founded Space Settlement Design Competitions, industry simulation games that engage high school students in designing future space settlements. And on this particular thing, she is going to make her presentation and enlighten all of the students here. These events are complementary to the NASA Ames Space Settlement Contest, co-sponsored by National Space Society. The competitions have evolved into an international activity involving more than 1,000 students each year on 6 continents. That's all over the world. Anita's work with space settlement design competitions was recognized by National Space Society in 2008 with presentation of a Space Pioneer Award in the category of Educator. Anita has been a member of National Space Society and both precursor organizations since the L5 Los Angeles chapter OASIS was founded in the late 1970s. She is a member of the NSS Space Settlement Advocacy Committee and chaired space settlement sessions for ISDC in 2007 and 2008. Anita is an active member of 2 professional engineering organizations, the American Institute of Aeronautics and Astronautics, AIAA, and Society of Women Engineers, SWE. She is a member of the AIAA Space Colonization Technical Committee, regularly chairs technical conference sessions on space settlements, and has written technical papers about space settlement requirements, designs, and the triggering events that will cause space settlements to be built. Anita earned both a Bachelor of Science and Master of Science in Aeronautics and Astronautics from the University of Washington and a certificate in Systems Engineering from Cal Poly Pomona. Before his untimely death in 2009, Anita and her spouse, Dick Edwards, raced a J-24 sailboat on the Texas circuit and summer Wednesday evenings on Clear Lake near NASA Johnson Space Center. Her favorite vacation is a 2-week Grand Canyon raft trip she arranges every 3 years with friends, colleagues, and geology professors from the University of Washington. And I remember when I was trying to contact her, she was already taking a rafting in Grand Canyon. And that's how she could not contact me. Now, program agenda for Friday, that is today, the speaker's presentation. I would also request Abhishek Agrawal to introduce himself if he takes over the presentation. So, over to you. Most welcome, Anita ji. You like to be called Anita ji. It's an Indian way of calling with a respect. So, I will stop my sharing the screen, and now you will take over.
All right, thank you very much. It's morning here near Johnson Space Center in Houston, Texas. And when you see me looking to the sides, oops, let's back up, Abhishek. Go to the title slide. Yeah, there we go, thank you. We actually have the fringes of Hurricane Delta in the area. It's we're not at the center, but we do have feeder bands of rain and wind, and it could do anything out there. And in fact, if we lose power or internet here, then Abhishek can take over. And also David Chevron is on the call and can take over too. So you may have noticed in the introduction, and thank you so much for that introduction. I do need to update that resume. I apologize. I now take a Grand Canyon raft trip every year. It's not always 2 weeks. Also, I hope you noticed in the introduction, there are space settlement design competitions, which Abhishek and I and David Chevron work on, and there's a space settlement contest. which was founded in the National Space Society about 10 years after we started what we do. They are very, very different, although there are teams that prepare a design for my competition, our competition, and then resubmit it for the contest, and that the requirements for both events are very, very different. So we find a lot of people don't want to go through the rigor that we have in the competitions, so they will enter the contest instead. And I am indeed retired from the Boeing company. Actually, just to give you an idea of how fun the aerospace industry is, after 40 years in the industry, I was working on Boeing commercial crew, the schedule slipped. The senior project engineer, I'm expensive, so they laid me off after 40 years. It wasn't a willing retirement. And Abhishek actually started the whole concept of regions in space settlement design competitions. How long ago was that, Abhishek? Was it, what, 15, how many years? Oh, you must be muted. Oh, don't. Okay, go ahead. All right, so yeah, it's also Abhishek is, I think we can call Abhishek a serial entrepreneur. He has companies in India, and also he and I are partners of companies in the United States, actually in Florida. He is in India right now. He just got married. Congratulations, Abhishek. And
sorry, I was muted, so I couldn't say. I was saying things, and it wasn't going through.
Yeah. Okay. Hi, Abhishek.
Hi.
How long have we been doing the Asian regional competitions?
Since 2004, so 17 years now.
17 years. Okay. Now there are regions all around the world. Okay. Now let's go to the next slide. So the title of this is about educational and career opportunities, but because we're in the National Space Society, we're going to look at this a little bit differently. Let's go to the next slide. So you might expect that we're going to talk about university programs and present day career opportunities. We're not going to do that. We're in the National Space Society, so we are going to look at the future. And when we say events with National Space Society that predict future human activities in space, this is actually in the design competitions that we do, including Abhishek and David, that we do for high school students. We actually do the best we can to predict an accurate, if optimistic, way that the future can proceed in space. So we're going to share some of that with you here, and then look at what can be career opportunities. I'm presuming most participants are students or perhaps young engineers, but based on the predictions we do in the design competition for the future of human activities in space, we're going to discuss a little bit of what that can mean for your own personal career and educational opportunities. Next slide. So, oh, okay, good. Put the website in there. So starting in 1984, the design competitions have been describing expansion of human settlements, people living in space and doing economic activities in space. And it was compared to what we do now. The 1984 scenario was pretty crude, but it has gotten well, fairly sophisticated. David and I go to some of the same conferences, and David knows I get a lot of my ideas and material for writing these scenarios from what we see in real conferences that are happening right now. And we're finding some organizations are kind of stuck in the now, and then really some of the best material comes from the National Space Society and other future-looking conferences. So we've been talking for decades about economic activity in space, companies working together in a consortium, which we call SEAC, which is a Space Enterprise Applications Consortium. It's not a real thing, but anyway, well, I'll get into that later. So companies working together and infrastructure being developed in space. It wasn't until maybe 4 or 5 years ago that the word infrastructure was even showing up in real space conferences. We've been using that word to describe how space will be developed.
David, I think Anita got dropped. Do you want to continue the presentation till she comes back?
Okay. Let's see, Abhishek, do you want to, I think you were first in line for
I'm back.
taking over. Do you want to go ahead?
I'm back.
Okay.
Hi, I'm back. Sorry.
Hey, good. We hear you.
Sorry, that happens here. Not enough bandwidth on the Wi-Fi in this little town. It's a contract problem. Anyway, so we're seeing now the things that we've been suggesting for decades are starting to show up in real conferences, and how the human economy is going to grow. We see presentations about satellite repair on orbit. Actually, just in the last few months, we're starting to see there's work going on at International Space Station to grow retinas, human retinas for your eyes in space, to fix certain kinds of blindness, to help people see again. We're seeing presentations about 3D printing cartilage and making growing organs for the human body that you can do in zero gravity and you're not able to do here on the ground. So there'll be exciting new opportunities for businesses in space. And it just means creativity and innovation, which are hard things to do. The idea of a consortium of collaboration between companies, we're seeing that happening. It's starting to happen. And the word infrastructure is showing up a lot more now. Okay, next slide, please. Oops, did we miss one? There we go. So what we do in a space settlement design competition, we recreate the experience of working on a proposal team in industry. And I have worked on a lot of proposal teams. These are events where, well, not events, a proposal team may last 40 or 60 days. I know David has worked on them as well. Literally a customer says, we want an international space station. How are you going to build it? And the company puts together a proposal describing how what its design is and how it's going to build something. And then the customer selects one of those companies. So this is how companies get work. Literally, this is how we stay employed. But when you're working on a proposal team, it's not unusual to be working 12, 16-hour days, 7 to 7-day weeks. And for me, it's the most fun an engineer can have. It's brutal work hours. But we do that to students. Now we do provide an organization chart. The items in blue, I'm going to show you examples. And the way it works with real proposals in industry is there's a request for proposal. So we write one of those as well. And I'll show you a short example of one of those. We set all of this in the future. We describe infrastructure development. So we give students a background for what assets are available in space to help them design and build their space settlements. And we have volunteers that we call CEOs, chief executive, chief executive, is that what it is? Executive officer. It's been so long since I've been in the industry. We just call them CEOs. And David has done this a lot. There may be even people on this call who've had David as a CEO. And the volunteer, these are real engineers and managers from industry who guide students through the process of working like a company. Now in the US especially, it's all about the experience. It's not about the winning. We know in Asia, it's mostly about the winning. But we see, when we do surveys of students, we'll see responses around 90% of students saying that this literally, this activity changed their lives, helped direct their career path. Next one, please. So this is the organization chart that we have the students use. This is much less complex than, chief executive, there we go. Much less complex than what's going on now. In the 1980s, something called matrix management was invented, and it makes organization charts really, really weird. This is more like an organization chart from the 1950s. So the chief executive officer at the top, that is a real volunteer. Actually, we usually have 2, even 3 volunteers helping guide the companies. And we'll have usually 50, and in the finals, 60 students will will be assigned to these roles. So there's you can see a president is a student, 2 vice presidents, directors of 4 engineering departments, and everyone else is either staff to the vice president of marketing and sales or working in one of the departments. Next one, please. And now this is an example. I don't expect you to read that stuff on the right. That's just intended to show you that we pack in a lot of text. And actually, this is a short request for proposal. It's for a habitat. We call it a mini scenario. The RFPs for the large settlements are 4 pages of packed text, and all of that is requirements. And notice the organization chart had 4 engineering departments: structures, operations, human, and automation. And we craft the request for proposal to follow that same organization, those same topics. And everything we can think of that's needed for a human settlement in space can be incorporated into these 4 topic areas. So operations and infrastructure includes air, water, human factors and safety, clothing and shoes. Everything that we need in space to live can somehow be packed into those 4 paragraphs of requests for proposals. The items shown in green will change for every proposal. The ones you're seeing here are for a lunar habitat, but what we call the 2 point or the X.1, 2, and 3 paragraphs, those paragraphs always cover basically the same topics. Now there will be details and nuances that will change. And then the X.4 paragraphs, and for some competitions, we'll even have X.5 paragraph. Those will change depending on the particular scenario. And we do ask students to compute cost and schedule. And for the finalists, for the large 4-page RFPs, we have another section called business case, which is section 7. Okay, let's go to the next one. So we write a lot of scenarios. We have a 5-year chronology of scenarios. So if a student happens to be between 15 and 19 years old for 5 years, that won't work. Maybe it would. But if a student is eligible to participate in the competition for 5 years, that student will see a different scenario every time he or she competes. Now we do rotate through those scenarios. So every 5 years we repeat. And we'll get into that a little bit more. So the kinds of scenarios we do, we have something called a qualifying competition. And I think Abhishek will explain more of that for Asia a little bit later on. The qualifying competition is a project you do in your school. We actually know schools that will incorporate our scenarios for qualifying competition into their curricula. So students actually are doing this as part of classwork. And these are large orbital settlements. And in fact, it's a 40-page written report that is the product. And this is actually the product that can be resubmitted for the space settlement contest that the other space settlement design event that National Space Society sponsors. For semifinals, like what we do in Asia with Abhishek, it's a large settlement for 5,000 up to, we've done them as big as 80,000 people. These are small cities. And they may be orbital or on surface. And then for the finals, our toughest scenarios are always on a surface. So that's either the moon or Mars, or in year 5, we get to Mercury and Venus, and those are a lot of fun. And we're getting way in the future when we do those. And then we have 2 minis every year. I don't write one every year, but most years we have 2 what we call mini scenarios. And these can be used by regions for local events, or there's some events that just aren't even related to the whole international setup. Just it's what we call a one-off. And we usually write one, it might be a habitat, like a mining camp on the moon or on Mars, and then we'll have one that's orbital. Okay, next one. And actually, we have names. We have a naming convention. So look at what we're saying people will be able to do. We're doing manufacturing, we're refining ore, we're doing commerce. I mean, if you have a port of entry, that means you have customs and banking and commerce in space. We actually also describe a university town in space. An Aldrin cycler, yeah, that's named after Buzz Aldrin, Dr. Buzz Aldrin, who, that's Buzz Aldrin from Apollo 11, who also still goes to National Space Society conferences. If you want to meet Buzz, come to a National Space Society conference, and you probably will be there. So we talk about large settlements actually used for transportation between Earth and Mars, a cruise ship, mining in the asteroids. And we even have a scenario for terraforming Mars. Oops, we're missing the bottom there. Anyway, so we have a wide diversity of scenarios that we have students design. Next one, please. Okay, and this is actually from, I think, the second year of the chronology. So we actually have about 14 pages of what we call future history in the program book that go into more details on this, but we're talking about the possibility of, or the probability of hotels. And Hilton was actually talking years ago about an orbital hotel, but those ideas are coming back. There's a conference that National Space Society is going to have next month in November called the Space Settlement Summit. And one of the presenters will be from Royal Caribbean, the cruise ship company. So there are, and other presenters will be from Procter & Gamble. I'm sure they are also in Asia, but here in the United States, every household has Procter & Gamble products. It's soap and laundry detergent and dishwashing stuff. And it's a company that provides products everyone uses. If there are humans living somewhere, they're probably using Procter & Gamble products or products made by another company that are the same kind of thing. Next one, please. Next slide. So what we require in these scenarios is there has to be an economic justification. So we are making these literally as realistic as we possibly can. As I said before, we get ideas from conferences. We write what we call a press release. It's a companion to the request for proposal that describes why the customer wants this particular space settlement, what it plans to do there, challenges associated with a space settlement. An example of a challenge would be on the moon. Lunar dust is incredibly abrasive. We realized maybe 10 or 15 years ago that the spacesuits used in the Apollo program on the moon were trashed. The longest any of them had been in use on the surface of the moon was about 24 hours. And there were leaky joints and frozen joints and abrasions and they were just a mess. And that was after only 24 hours. Well, if you had that happen to the main airlock to your space settlement on the moon, everyone would die. Either it wouldn't work or it would leak and you lose all your air. So that's a huge challenge, is how to deal with lunar dust. Martian dust is less abrasive. On the other hand, it's blown by the wind, so it gets into more stuff. And actually, I haven't been on the moon and I haven't been on Mars. I haven't touched lunar dust, but I imagine it's somewhere smaller in particle size than what we see in the silt at the bottom of the Grand Canyon. And actually, on this last raft trip, I found some deposits of calcium carbonate on the edges of, or on the banks of the Little Colorado River, and it's a very powdery, like flour-like substance. So Mom Nature can make some really fine powders that can really be nasty for getting into equipment. Another challenge is on Mars. Believe it or not, the conditions on Mars are not all that different from conditions we can find on Earth, including temperature ranges, or the moon, or in space. It's less gravity. There's just enough atmosphere.
Hello, Anita. Is it that Hurricane Delta affecting your presentation?
Yeah, it's possible that it is. Abhishek, do you want to continue?
Yeah. Abhishek, would you like to take over?
Yeah, if you give her a few seconds, she should be back. Otherwise, I'll take over.
Okay, okay, okay.
Yeah, let's just give her 35 seconds and then
Okay, okay. No problem. Meantime, friends, we have shared the link of onlinequestions.org. Please ask your questions on that website so that it can be compiled and weighted about the importance of the question, and then the answers will be given by the speakers.
also shared on YouTube chat window also. YouTube chat or window share
And this has been shared on YouTube channel also.
So I'll continue, and then when she comes back, she'll take over.
Okay, okay, okay.
Yeah. So one of the biggest challenges of building in space is gravity, right? It has adverse effects on our bodies. It has Anita, you're back. Why don't you take over?
Let's see if, there we go. Yeah, sorry. Okay, I think I'm unmuted. Sorry. Okay, so we talked about challenges. Sorry about that. It's just the way it is here. And thank you, Abhishek, for picking up again. So yeah, I was just saying that Mars has enough atmosphere to be a problem and not enough to be a benefit. And I'm presuming that, Abhishek, you were talking about the 5-year intervals. I'm going to emphasize it. There are a number of schools, especially in Asia, that literally will retain copies of the RFP. And when we redo a scenario, quote unquote, when we go through the 5-year process, they look at the old scenarios and we'll try to design stuff to do designs in advance and bring it to the competition. That literally, my job is to make that a waste of time. So there are enough differences in the scenarios every 5 years that if you try to design to a prior scenario or a prior request for proposal, you're going to do it wrong. So don't even try. Just do it the way we intend. Okay, next one, please. Next slide. Oops, did we skip one? Yeah, I think we skipped one. So this is actually, when you see that oval and it says from SSDC, this is literally a slide that we present during the design competitions. So we make this experience as accurate an approximation of being on an industry program, or industry proposal team as possible. So the customer is very demanding. I try to be absolutely evil when I ask questions when the students are presenting. I'm so bad. It's very challenging. The task is hard. The deadline is short. And really, it's about industry skills. If it's about managing and working as a team and communication. And as we said earlier, what we've been representing in the design competition is starting to be heard at conferences. So the idea of partnerships and consortium and infrastructure and economy, those are showing up for real. So not only is it a very realistic experience, but the scenarios that we're proposing are starting to match with what's happening for well, let's say industry's catching up with where we've been for years. Next one, please. So when I say it's a challenging schedule, so the students receive the request for proposal, actually 10:30 a.m. on, this is a normal schedule, 10:30 a.m. on a Saturday, and by 7:30 on Sunday, so it's 21 hours later, they have to have their design completed and on briefing charts and turned in for presentations starting at 9 o'clock. This will be in a group of 50 students, most of whom never met each other before this starts. And this really does simulate the challenge of being on an industry proposal team. Next slide, please. And it is international. I was going to highlight Asia, so top left. Abhishek can talk more about the Asian semifinal, but literally 2 teams come from Asia and are invited to the finalist competition. Now, clearly this was done virtually this year, although we did have a core team at Kennedy Space Center. We really like to have 250 students at Kennedy Space Center. It's great. Next one, please. We do allow the regional coordinators like Abhishek to run their region differently. There are different cultures and different ways of doing things. In the UK, for instance, there is a huge donor and this big charity infrastructure and laws and all this kind of stuff. In the US, we're a bit more relaxed. In Asia, all those benefits in the UK don't exist. So in every venue, how the local competitions run is different. We do ask that every region uses the scenarios provided for the Space Settlement Design Competition so that the students get a feel for what it's going to be like at the finals. Let's go ahead to next slide, please. So what do we predict? You've seen some of this. Mentioned on-orbit satellite repair and servicing. We predict that International Space Station is going to be turned over to a consortium of companies. We're actually starting to hear that in industry. We see that there are companies that literally have designs for things like space tugs and fuel depots and vehicles you've never seen before. Those designs exist, they just haven't been paid for and built. So we're predicting that companies will get together, decide who builds what, not compete, but collaborate. Reducing launch costs is really important. We actually see the first lunar habitats, and we have a scenario for this. We see lunar habitats for literally just planning habitats all over the moon and figuring out what's there and how can we use it and what can we make from it. We also have noticed that for space missions with astronauts and cosmonauts and taikonauts, and that the astronauts' time is all scheduled. They don't have any free time. And we know the way human creativity works is if you have unscheduled hours, and the 3M company, famously in the United States, the 3M company actually allocates, I think it's 10% of its engineering hours to just do whatever you want in the lab. And there are amazing inventions that have come out of engineers just being creative, doing whatever they want. And we need this, amazing inventions from that. We presume that new materials are discovered. Whoops. And then since I'm a cargo person, that bottom one, we actually define a cargo containerization system. So cargo containers have completely changed shipping on Earth. And I see that cargo containers will also completely change shipping in space, but there'll be a different configuration. And actually the configuration of the cargo container, which we call a cask, it's an acronym, the space cargo containers configuration will be different, and it's actually based on a proposal that I wrote and the configuration we defined for that proposal. Next one, please. So to do all of this stuff, you need infrastructure, and you look at how civilization runs, and there are highways and power, water. This is infrastructure that everybody and everything shares, and we need this in space. In the space, what we call the Space Settlement Technical community, let's call it, what we see at conferences, people have been focusing for decades on how do we get to space quickly. And everyone's looking at this. And I've been nagging in the background. It's not all about me, but I've been nagging in the background. Hey, there's some stuff we can do now, like this is 30 years ago, to enable settling in space to happen sooner rather than later. And everyone's looking at cheap access to space. Well, now SpaceX and even United Launch Alliance and Blue Origin and other companies are working on that. So finally, the real space settlement technical community is starting to look at infrastructure at last. Let's, next one, please. So what kind of infrastructure are we talking about? Well, basically, everything that's part of infrastructure here on Earth needs to be part of infrastructure for living in space. And that includes consumer commodities. So I am literally in my kitchen. These are cookbooks here. That's not a library, that's cookbooks. Yeah. Look in your bathroom, soap, toothbrush, toothpaste, toilet paper. Those are all things that people will need in space. And you don't want to ship that stuff, those commodities from Earth. You want to be able to make those commodities in space, so you're not absorbing the launch costs. If toilet paper costs $10,000 a roll, that's going to be a problem. Okay, next, please. There's also unique infrastructure that will be required in space. So it's not like here on Earth where I literally can walk out a door that I'm looking at in my backyard, except it's unpleasant out there right now with a feeder band from a hurricane out here. It's rainy and windy and icky, and dark. Here on Earth, you can just go out a door and walk. Well, in space, it's not quite that simple. You need different kinds of vehicles. You need to solve the dust problem. You need spacesuits. If you're in orbit, you need a way to keep yourself attached to things. And these challenges are all documented and have been looked at for years. We just need to get out in space and start really doing it. There have been experiments like Biosphere 2 in Arizona. There have been experiments to how do you keep an entire ecology alive inside a space settlement. We need to get smarter about that too. Space station has been keeping people safe and oxygenated and fed and healthy for decades now. What, 2 decades? So we've shown we can at least keep a small population safe in space. But a problem with what we've been doing in space before I lived in the Los Angeles area for a lot of years, and it's kind of like the way a movie production works is everything is either bought new or rented new, and about the only thing that's used from one movie to the next is the telephones and the cameras. And other than that, all the sets and background stuff are developed new. I have some stories about that. At Rockwell Downey was used as a movie production set a few times, so we got to see in person how this happens. So space station has a toilet that's different than what was used on Space Shuttle, different than what was used on Soviet and Russian vehicles, and different than the Chinese vehicles. And actually a new toilet was just launched to space station. We need things to be standard in space, just like they are here on the ground. You need to be able to go to the plumbing store and just buy it, and it fits, and it works with the plumbing that you have in your house. And we just haven't gotten to that point in space, but that will need to happen. Okay, next, please. Doing pretty good on time. So when we have infrastructure, that just makes everything less expensive. If you need water, you just hook up to the water supply. If you need air, you just order air, and the air provider brings it to you. And once you have these difficult commodity providing structures and infrastructures in place, then there's all kinds of stuff you can do. You saw this alluded to on prior slides. So we predict that people will start in low Earth orbit and have habitats on the moon to do mining, and from that we'll have unique products, and then we'll refine and manufacture in orbit. We'll do a road infrastructure and communications and navigation infrastructure on the moon. Eventually banking and commerce, eventually expand to Mars. You haven't seen much about NASA. And what we're seeing in the conferences these days is NASA started as something called NACA in 1915. And so this might sound kind of engineering-y, but for analysis and research that could benefit all of the aerospace or airplane companies at the time, NACA, it's not NACA, it's NACA, was doing things like like analysis and testing of wing sections, so the cross section of a wing, and what are the lift and drag characteristics of that. So that is research that can help everyone. So we need NASA to do things like standard spacesuit designs that will help everyone. Also, NASA can be a customer for exploration and science. So NASA can be a customer for the vehicles that are provided by industry. Next slide, please. So when the economy of humans expands into space, some of those commodities are going to be, and I think you had a presentation from, actually you had a presentation from John Mankins, who's the solar power satellite guy, but it was on a different thing, and then someone else did one on solar power satellites. But we actually, David and I know people. We could name names. We know people who are looking at power from solar power satellites, fuel depots in space, commodities like water and air from lunar resources. There was a NASA study that I'm still itching to see the report from it. I'm looking at the economics and chemistry of developing commodities from lunar resources. How do you grow food in space? That's being looked at right now. Made in Space, which was just acquired by another company, is looking at 3D printing of structure. Wow, it's really getting windy outside. Recycling is being looked at. And what we say in the design competition is there will be subcontractors that are providing these commodities, this infrastructure for everyone and everything that lives in space. And let's look at the subcontractors list on the next page. So we give things funny names, mostly so the judges know which subcontractor you're talking about. But look at, and this isn't all of them. This is just part of the subcontractor list. And David and I literally know people who are looking at how to do these kinds of things. I've seen presentations on how excavation equipment will be designed differently for lunar and Mars excavation than here on Earth. And part of the reason is a lot of excavation equipment depends on the weight of the equipment. You dig a shovel in the ground, and the weight of the equipment enables you to dig into the ground. Well, if you only weigh 1/6 as much, you may be just lifting your equipment off the ground. So things need to be designed very differently. We kind of highlighted litigation limiters there. In the design competition, we define products of major companies, and we say, and we think this is how it'll work in a consortium. Even if your company has a vehicle, any other company can use it or buy it or have the services. So we really need to have much more cooperation and collaboration in space than we find with companies literally stealing intellectual property here on Earth. We need to have a free and open exchange and trust involving company products to really accelerate how we settle in space. So anyway, these are, and I'm actually going to show you this list again later in the presentation for another reason. Next slide, please. Okay, so the experience is extremely challenging. You're working with people you don't know. You don't have much time. At the finals, it's international, different cultures, different education backgrounds. It's a huge request for proposal. and I'm going to thank David for the next few pictures here. And for some students, we've heard just the fact that they need to speak and do a presentation in front of a large audience literally is a life-changing event for some students. Let's go to the next slide. So thank you, David. This is a nonverbal, yeah, David and I love this one. This is actually taken in India. This is a universal nonverbal. Oh my God, what am I doing now? Next slide, please. If you look on the lower right, 5:49 a.m. and the kid's just asleep at the switch there. So kids literally do work all night. Next one. This was Dawn in Seattle, and so there's the girl with her hand on her forehead. Look behind her, just to the left of her, and there's a kid flaked out on the carpet, just collapsed there. He's not passed out. He's just kind of, well, he just fell asleep on the floor in the middle of everything, completely exhausted. Next slide. On the other hand, what the students do is absolutely amazing. And for anyone who's worked at proposal, what you see in the upper right is called a wall walk. And this happens in real proposal teams where you put all the pages of the proposal up on a wall and everyone has a chance to look at it and critique it and make sure it's consistent. And we literally have students doing the same thing. And a lot of this is at the suggestion of the volunteers who've done this themselves at work. Next one, please. Thank you, David, for those photos. Okay,
You're welcome.
So, great stuff. So what students learn is literally we get feedback from students after they've gotten into college. A lot will come back as volunteers after they've gotten into industry. Literally working in an organization chart where there are responsibilities of departments, that is not taught in high school. It's not taught in college. And that's how industry works. So literally students who go through the competition know more about how companies work than a lot of engineers who've graduated, who've been out of college for 5 or 6 years. Just because the students who do this activity have learned about these management, teamwork, communication, organization chart challenges. We find every student has a different experience, and you've got some quotes there. On my screen, we lost the college student example. So what high school students learn is this might be what I want to do for the rest of my life, or not, and that's fine too. The college student quote was, I had no idea how important this human factors stuff was. And this was an aeronautics and astronautics student who was going to design airplanes and didn't realize that when you're designing something for humans, you really need to pay attention to human needs. So it has a lot of value. Next one, please. Okay, so the topic of this talk is educational and career opportunities. So let's look at career opportunities. We know that engineers will be needed in the future. And we're talking about future career opportunities. And when people live in space, every engineering discipline will be, even environmental engineering will be needed, but packaging engineering, all these obscure engineering. It's not just aeronautics and astronautics or mechanical or civil engineering. All of the kinds of engineers we need for people living on Earth will be needed when people move to space. And they will be doing all the same things that engineers do here on Earth: design, analysis, test, just everything. So a recommendation we have for students, or for college graduates getting into industry, you may have graduated from an elite school and your professors may tell you now you can change the world. And especially if you work in an established company like the Boeing company, you're working with people who've been doing it for decades. Industry tools like analytical tools, the things that industry is doing, especially in the aerospace business, are 10 to 15 years beyond anything you're seeing in college. So take that shiny new college degree, get out into industry and shut up. Just be quiet and learn from what the old fossils like me have been doing for decades. It's the smartest thing you can do for the first 3, 4, 5 years of your career. Accept yourself as an apprentice. Don't try to change everything when you don't even know what they're doing. System integration is very important. Everything relates to everything else. We're not going to go, we could do a whole presentation on system integration and system engineering. And then we're going to look again at that subcontractors list, because those businesses described on the subcontractors list, if you want to be an entrepreneur in the space biz 10, 20 years from now, look at that subcontractors list for where you might start. We have said that we know people who are working on those. Well, it's always good to have competition. But it's not only engineers. There are actually design competition veterans who were, one of them calls himself a wrench turner. So, somebody who's building stuff, hands-on. Pad rats are people who are working on the launch pad preparing vehicles. Preparing launch vehicles. We will need maintenance technicians in space, keeping these space settlements running and these habitats and mining operations and refineries. No matter what career you go into, do it well, because if you're interviewed to do it in space, they're going to be looking for the best of the best to go do it in space, where the stakes are much higher. Keep your eye on the news, and if you join National Space Society, you'll see what real companies are doing, and you can kind of keep your finger on the pulse of what's going on in space, so you know when to start looking for a job to interview for in orbit. Next one is the subcontractor list. So again, there are so many opportunities if you want to be an entrepreneur. People will need air, people will need water. That soil solutions, converting dirt to soil. Dirt is dead. Soil that you grow stuff in has biota in it. So just trying to plant a plant in lunar dirt will not enable it to grow. You'll have to figure out how to turn it into soil. Every product that people use on Earth, there will need to be an equivalent in space, and it'll be more economically feasible if it's made from space materials, probably lunar and asteroid, because then you don't have the launch costs. Next slide is about, so how do you craft your education to prepare for this? Well, okay, engineers are needed. There are a lot of colleges that are not the name brand. I talk to students in Asia all the time, and they want to go to MIT or Stanford or Cal Berkeley or Caltech. There are great colleges in the US and Britain and Europe, and even in Asia, there are great colleges, some of which you probably never heard of. Cal State Fullerton. You can get a great education in engineering at California State University in Fullerton. Now, you might be in mechanical or civil engineering, but those disciplines will be needed. So you don't need to apply to only the greatest schools. Look at other schools as well. And by the way, participating, not necessarily winning, participating in a space settlement design competition, our alumni tell us, it looks terrific on a college application. And a lot of times students get a better college application essay from losing in the competition than from winning, because you can talk about what you learned from losing, and that shows character building, and college application reviewers really love that. Do get good grades in school. The people who are going to go to space and work on spacecraft are the ones who are good grade earners. On the other hand, when I hired engineers, I did not want to hire a grade producing robot. I never hired a grade producing robot. I would rather have someone with B+ than with A grades if that person has been involved in campus organizations. So depending on your campus, there will be chapters of American Institute of Aeronautics and Astronautics, the American Society of Mechanical Engineers. By the way, they say American, they are global organizations. National Space Society says national as in United States. It's a global organization. There are technical societies for chemical engineering and civil engineering, any packaging engineering even, systems engineering. So get involved in student organizations if you can. Get elected to a leadership position, and that goes on your resume for applying for an engineering job in industry, and do of course get that degree. Now you can get some college education and go into industry as they don't call them draftsmen anymore, a computer-aided design operator. There are lots of trades. So we mentioned 2 slides ago, other professions will be needed. So learning how to be an aircraft mechanic or a spacecraft mechanic will be an essential skill. There's going to be a point where we have restaurant workers and cleaning crews. Just make sure whatever it is you choose to do, or wherever your career leads you, or whatever you choose to follow, just do it well. And literally, if you wait long enough, we don't know how long that is. There are people who say that there'll be habitats in space in 10 years. I'm thinking more like 15 to 20 years. But I expect, unless something really bad happens, within your lifetime, people will be living in space and basically running communities the same as we run communities on Earth. Every profession will have a place in space. Next one, please. We're very near the end, and then we can take questions. So if you want to get involved in space settlement design competitions, you can register at, in Asia, register at arssdc.org. We are also prototyping what we call a tournament format. We've started this, David and I are starting this in Brownsville, Texas. We intend to make this available to deploy worldwide. I don't know if Abhishek is ready to do this in Asia yet, but if an organization or a school district or a company or a Rotary Club or an NSS chapter, we know one in India, wants to put on we call it a one-off. It's an independent space settlement design competition. We'll be happy to work with you on that. So every region is different. Abhishek, take it away and describe the process for Asia.
Yeah, so the process is it's a team competition. You form a team, could be up to 12 members. There is no lower limit, but we advise that you have at least 6 to 8 members to form a team that can get the job done. You can have different students from different schools make a team, or you could have multiple teams in the same school. It's a professional competition. We do not have those restrictions that academic competitions usually carry. Registration is online. The qualifying round is open till October 28th, so you still have about 3 weeks. The submission deadline is November 2nd. So if you are serious, you should try and get a team together quickly and then go and register online. We will send you the RFP, the request for proposal, and then expect you to submit make your submission by the deadline. We will be holding the Indian Nationals virtually this year because of COVID. We might do the Asian semifinals virtually as well, but we haven't made a decision on that. And the international finals will be in July in 2021. So if you want to participate or get more information, this is our website, arssdc.org. It's for Asian Regional Space Settlement Design Competition. Thank you.
All right, and last slide. We'll be happy to take questions, and we allow plenty of time for questions.
Yeah, thank you. Thank you, Anita and Abhishek, for a wonderful presentation. And the last slide was the most important slide, the timeline given for participating in the competition. That's a very important one. David, have you got any questions on that website, onlinequestions.org?
Yes, I do, but we're having a little bit of a problem with it, so I'd like to ask people to try one more time. Change to event number 10368. I've got your old questions that were submitted before, but I'll give folks a little chance to put some final questions in with event number 10368. But this is why we test. So go ahead, Avinash, and ask your questions for your process first.
But take up only those questions which are relevant to the topic of today, because many people have asked many questions which are absolutely irrelevant. But anyway, Anita and Abhishek, I will ask you one question. One Mr. Amruta, she is asking, I want to pursue my career in astronomy and astrophysics, and I am currently in my 12th grade. Is it better have my bachelor's in physics or directly join an undergraduate program for astronomy?
Wow. So I'm not a scientist, I'm an engineer. Really, I think the answer to that depends on the university that you go to. If your university has an astronomy program, I personally would go straight into astronomy. Just declare it from the beginning. If your university has an astronomy program only at the graduate level, then start in physics. You can ask your high school guidance counselor. Depending on the university you go to, you may be able to get help with that question from the university admissions people.
I have a different take on it. Okay. I would always suggest people to take up core studies before they do specialization, because it keeps options open for you. When you're looking at the world in grade 12, you look at it from a very small aperture. And as you grow older, you start looking at things differently. So I would suggest if you're interested in physics, you should take up physics as your core studies and then always you can do specialization in your master's and PhD.
Yeah, that's really a good answer. Next question is, what is the competition's age group? That is, what is the age or school grade criteria for participation?
Okay, it's high school. And we ask that students be at least 15 years old. Now, they're in the UK, they actually have a kind of a lead into the competitions with younger people. So some regions will have events for younger people that are based on the competition. But to get into the Space Settlement Design Competition, at least 15. By the way, if one of those irrelevant questions is, did the Apollo lunar landings really happen? Because I know people ask that. Yes, they did. I mean, I know people who walked on the moon. Well, most of them, not all are dead now, but and really remember your history. It was the Cold War. The radio transmissions were coming from the moon. If they were not, the Soviets were monitoring, and the Soviets would have splashed it on the front page of every newspaper around the world that the radio transmissions were not coming from where the Americans said they were coming from, which was the moon. So if anyone has that question, just put it to bed. We also know we've been to the moon because there was a class of meteorites that were not identified until we brought back samples from the moon and they matched the lunar material. So yes, we have. So if anyone asked that question, there's the answer. Okay, next question.
Yeah. One question is, what type of financial aid is given to the participants as an individual or as a group or as a team?
We don't have any financial aid for participation. It's entirely up to the schools to raise funds for participation.
But in the beginning, I saw that the 50 students are assigned to the companies, and the company CEO and MD and engineers and other people, they guide the students for their project.
Yes, but that's not a financial aid. That's technical aid. We provide plenty of technical aid.
That's right. But how that is viable in India? Have you sorted out or found out some companies where students can be sent for this type of project?
No, so when they come to the Indian nationals or the Asian semi-finals, we have volunteers who travel from all over India. Last year we had six Boeing engineers who came from India, and we have several engineers engineers and scientists like Anita and David who travel from the US to help run the competition.
Okay, so I think there are no more questions, but what I like 2 sentences of your presentation, that till I participated in the competition, I learned that I really don't know anything. That is one. And second is, this competition is the reason I am an engineer. And last but not the least, space is vast, so the opportunities. So we have ample opportunities. Sky is not the limit. Space is not the limit for our opportunities, for learning, for education, for training, and for experimenting. So I wish next year or next to next year, the ISDC will be flooded with Indian participants, as 2018 were 103 and 206, and last year 203 students from India. So the number will increase, and they will be from all the parts of the India. Thank you very, very, very much.
Okay. So Avinash, I have questions now that have been ranked, so
okay,
I'm ready.
Okay, over to you.
Okay, so the top ranked question now: is there any possibility for infrastructure development on the moon in future years?
Oh, absolutely. Literally, David, you and I know people who are looking at that right now. So absolutely. There are some folks who think we might have some infrastructure development as soon as 10 years from now. And by the way, when we're through with the questions, David, if you have anything else you want to add, then I'd like to solicit your whatever you want to say as well.
Oh, great. Okay. So the second top ranked question was how can space settlement help people on Earth?
Oh, well, okay. So actually, we're starting to see experimentation on International Space Station. I mentioned growing retinas, artificial retinas, so literally curing blindness, growing artificial organs. And one of the things that happens when you go to a new environment is, at least we think, that on the moon, especially on the backside of the moon, it is highly likely that impact chemistry in the bizarre conditions of the moon may have created ores and compounds that we're not familiar with maybe unique properties. So we may be able to find a material on the moon from which we can make better aircraft engines, who knows, better anything, better solar panels, perhaps products that we never even thought of before, materials we never thought of before. And actually in the competition scenarios, we describe just speculations of new materials that can benefit humanity. I personally think what looks like the first immediate benefits for people on the ground are going to be in the medical field. And we're just seeing a start of touching the surface of what can be done for medical benefits in space.
Okay, and one other that was equal ranked for a bit there says, since we can't speak in space, that would be a major issue for industrialization. How would you tackle this problem?
Since we can't speak?
Speak in space.
Like speak,
So,
like talk.
Like I guess sound doesn't carry in space, so
that's why we have radios.
Radios, yes.
Yeah.
Okay,
Exactly.
well those are
yeah. If you can't breathe, so we have to be able to breathe, and you can have a radio. And I hope I answered that question.
okay. And okay, so there was a couple others that were related to the ages that students can participate in here, the starting ages, and one that was relatively high ranked in that, not a top one, but I could maybe address here. This is how can a first year college student join this competition? And I'll let you go first with that one, and then I've got an idea for that.
Yeah, you got to follow up. So right now, I focus on high school students. I have done a competition for a university, my own university, University of Washington. That was a special circumstance. If an organization, in fact, there is discussion among National Space Society leadership right now of maybe having a parallel organization starting some college level competitions, but that hasn't formally started yet. Now, college students can join as volunteers, but David has been working on something that definitely involves college students.
Yeah, so a thing I've been working on, it's only been run twice so far. We're just in a limited prototyping stage with this, but I've put together a parallel space settlement entrepreneur competition where what we would do is have small companies or small groups of students that want to form companies to try to put a business plan together to come up with a new space company like those on the list that Anita showed with all those contractors, the subcontractors. So we allow for that to run in parallel, and the college students get to do their entrepreneur business plan with a Shark Tank-like, for lack of a better word, a judging panel and we've had real space venture capitalists come in as judges, and they get to pitch their ideas for their space company. And they also, during their development of their program, their company, they get to go meet with a subcontracts manager from the large company that's going on in the traditional space settlement design competition and see if their new company is providing a product that the big company wants to incorporate in their proposal. So we're simulating that whole process of starting a new company and going out and doing the marketing and trying to get business from that company. So that's we can't say that's a thing that we're doing regularly, but we're occasionally trying that, and we've got a lot of interest in it. We may do some more. There's also secondarily, we've got this tournament that we're doing, and that's up to different organizations how they want to run the tournament, but they may want to run a tournament at a college level. So that's a possibility. So you stay tuned on that. And that's, I think, about all the questions that
I see someone saying, please, can the lowest age to 13. So the reason we constrained to 15 years old is we have had 14-year-olds, even an 11-year-old in a competition. And I know anyone younger than 14 won't believe this, but we have noticed that between age 14 and 15, something physical changes in your body. And we find that literally 13 and 14-year-olds just are not able to do the all-night thing. Literally, it gets to be 11 o'clock at night or midnight, and their little bodies just shut down. We don't want to damage anyone psychologically or physically. So we wait until age 15 when your body literally is developed enough that you can physically handle this event. It is that strenuous. That's why we do it.
In India, in Asia, we allow students from grade 9, sometimes grade 8, but mostly grade 9 to grade 12 to participate.
Okay, I think there are no more questions. So thank you very, very much, Anita ji, Abhishek, David, everyone, for your valuable time from a very busy schedule. I understand how busy you are. So,
okay. I'd like to thank everybody for helping test this question ranking tool.
Thank you.
And thank you for the opportunity. It was fun.
Please wait. I have to make an important announcement for tomorrow's program. Tomorrow, Saturday, 10th October, please, please, please pay attention to the time of the program. Till last 5 days, we had programs every day in the evening. Tomorrow, we have a program at 11 a.m. up to 12:30 p.m. The speaker is a very, very eminent highest officer of ISRO. Padma Shri A.S. Kiran Kumar sir is the ex-chairman of ISRO. For the information of Anita ji, chairman of ISRO is equivalent to the NASA administrator. And he is also a president of Aeronautical Society of India. The subject of his presentation is the history of ISRO, that is Indian Space Research Organization, past, present, and future. So, I'm thankful. Before we depart for the day, let me acknowledge and thank Professor Dr. Mahesh Sanghvi and Raju Bhandari for their guidance, help, and assistance in designing flyer, banners, setting up Zoom platform, and YouTube channel. Thanks, Dr. Sanghvi and Bhandari. Thank you very much, and have a very good day in Texas and a very good night in India. Thank you. Thank you once again. And let me close today's proceedings. Bye-bye. Bye.